So, in this lab, our goal is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on a spring. To do this, we'll take advantage of fundamental principles, including Newton's second law, tracker data, our code, as well as data and modeling. And from this lab, we were able to find that our prediction model was able to accurately predict the updated location of the spring mass system, proving the validity of these fundamental principles. As far as the fundamental principles that we'll be using, or the formulas, we have the velocity update and position update formula. We also use the spring potential energy and the gravity potential energy, as well as the kinetic potential energy to find the energy of the overall system. And that will also help us find the net force, which we'll use to calculate the velocity and position update formulas. As far as the tracker data, um, I set the initial condition to 0.7 meters, and as you can see, we get this oscillating effect for both the x and the y direction, as the mass kind of goes around in a circle here. And so when you put it into the Excel graph, these were my two graphs for both the x and the y direction. As far as the code, these are the initial conditions that we were given from the video. And then in order to plug this in for calculations, I had to use I had to use the formula for the force of the spring and then the force of gravity to get F net. And then once I had F net, I could use that to find the updated velocity and position vectors. And then I also had to use the kinetic energy formula to find the formula for the total energy, which is just K plus potential energy plus the potential energy of the spring. And so when we run this, when we run this, I'm black by the way. When we run this, uh, this we can see. Okay, so when we run this, yeah, I'm sorry. Um, there's a discrepancy between the positions in the y direction, which was just, my mishap with putting initial conditions in. Um, but as we can see, as far as the actual positions in the x position, the y position, with time, um, they're pretty much the same if you account for the discrepancy in the y direction. There's a little delay, but besides that, they're pretty much identical. So I would say that the model was able to pretty accurately predict the updated position of the mass. As far as the change in total energy, for some reason, my delta E and delta K weren't showing up, but I would imagine that it would delta K would do something like this. It would be oscillating as well, of course, and then delta E should be a flat line because the overall total energy in the system should be zero. Um, yeah. So what does it mean? Is the energy principle justified? Well, you can't see from this because for some reason I hate code and the code wouldn't show up. But I would imagine that, like I said, the delta K would be oscillating, delta E would be zero, and if you add these three up, they should come out to zero because there's no the F net in the system is zero. And then as far as the second question, predicting the position in relation to the X and Y. Um, no, they would not be the same. They would be different, and this is due to different forces acting on each direction. So in the X direction, you just have the force of like the spring and velocity. In the Y direction, you have the force of the spring as well as the force of gravity acting upon it. And so in the right direction, you have another force added, which changes the position. Whereas in the Y, there's nothing else impeding it besides just the force of the spring. Yeah, that's it.